What's going on, folks? Hope you guys are doing well. In this example right here, we're going to go over, we're going to identify these different polynomials. We're going to dig down deeper and say which one is a monomial, a binomial, a trinomial, or just none of these, right? And if we look back from example number 1, we talked about how, this entire thing is all called a polynomial. All of these right here are all polynomials, but they actually get to more specific names, and that's what we're going to talk about right now. Okay, so real quickly here, what is a monomial? That just means one term for mono. Binomial is going to be 2 terms. Tri, like triangle, tri, is going to be 3 terms. And again, a polynomial, it just means more than one. More than one. So basically, something can be a binomial and a polynomial, a trinomial and a polynomial. You see what I'm saying? But only one thing can be a binomial. It kind of makes it more specific here. So let's come over here. Okay. So what is this right here? Okay. If we look at the first term, a to the power 4, b to the power 2, again, these are multiplied. This all counts as only one term because it's being multiplied. What divides 2 terms is either addition or subtraction. So since it's being subtracted here, we now have 2 separate terms. But when things are multiplied together, it's still one term. I mean, think about it. If I said 2, or if I did 2 times 5 right here, right? Well, that right there is not one term. This is not 2 terms. This is still one term, right? It's one term right there. So when we think about it, this right here is going to be 2 terms. Okay, so that's why it's going to be a binomial. This right here is just one term. It is one term, and so that's what we're going to call it, monomial. Okay, and I think I didn't really spell that all the way right. Okay, now come over here. We have 1 term, we have 2 terms, and we have 3 terms. So there we go, 1, 2, 3. So that means we're going to call this a trinomial. And then lastly, we have -6 n to the power 2 times n to the power 5. They're all being multiplied together. And that's fine. That all counts as one term, so this is going to be a monomial. Okay? Now, let me just make a note of a common error that I do see when students are kind of doing problems like this, and even when they get to even combining like terms, which we're going to get to in this section. Say if we come to something like this right here, and one common error I'll see is students may want to add -4 plus 10. So they'll say, oh, 6x, and then they'll add 5 and 3 together and then get 8. Okay, I mean, that kind of makes sense when you don't know all the rules, but yeah, that's what you would think you would maybe commonly do, but that's actually not true, right? So the thing about, you can't combine terms together, just like you can't combine those together, because they have to have two things here. And let me see if I can get my little highlighter here. They have to have the same base. Okay, so they each have the same base, right? X, great. But they also have to have the same power or exponent. And as you can see here, one's a power 3 and one's a power 5. So if they both don't have the same base, the variable, and the power up on top, the little small number, if those aren't exactly the same, then we can't combine them together. So that's why we can't do this right here. Okay, that's a no bueno right there. Okay, sad face. All right, we can't do that. And same thing right here. These have to be exactly the same. See how they have the same base, a and a, but then a to the power 4 and then a to the power of 1. So we can't combine those together, right? So that's what I'm talking about when we do start combining, or say, oh well, can't we combine this into one term? Only if it has the same base and the same exponent.